Okay, welcome to Pratidhvani, where we try to humanize science. I'm your host, GV Pawan Kumar. It is my delight and honor and a privilege to introduce you to my guest on this episode, Jayant Murthy. Jayant is a distinguished senior professor, an honorary professor now at the Indian Institute of Astrophysics, Bengaluru. Jayant has made very important and fantastic contributions in the area of astronomy and astrophysics. And his research interest includes interstellar medium, ultraviolet astronomy, space missions, etc., etc. And he has played a significant role in New Horizon mission. And very importantly and very fascinatingly, recently the asteroid, which was previously known as 2005 EX296, has now been officially designated as 215 884 Jayant Murthy. What a privilege and an honor, Jayant. Welcome to Pratidhvani.
Thank you, Pavan.
So, Jayant, I'm really fascinated to know how you really got interested in the sciences, specifically astrophysics and general science. Please walk us through your origins. Where were you born? When were you born? In what situation you actually got your education, etc.
Yeah, so this is a little unusual. I was born in Shillong. My parents were in Germany at the time, and my mother went. My grandfather was chief engineer of the Assam State Electricity Board. So
Wow. Okay.
I was born in Shillong, which is now Meghalaya, but at that time it was Assam. So he was there. So that's where I was born. I spent I think almost 4 years, 3 years, 4 years in Shillong. I hardly remember any of it. Just a few roads ending in lakes. Now,
Okay.
the roads were there, and then they built dams. Then after that, my father moved around a little. First, we went to Bhopal, and then we were working in. Then he was working in Bombay at the time. And I think the only memorable thing there was that I went to what's it called, Campion School, which I
Mhm.
think is a pretty. No, first I went to Convent of Jesus and Mary, and then to Campion School. I think both of these are Bombay institutions. So I went to Campion School actually, but I mean a few years ago. They weren't very interested in seeing me again. Uh,
Okay.
so it puts me in my place. Um,
So,
yeah.
this kind of interesting origins, what you have, also probably would have kind of exposed you to slightly more broader kind of cultures right at the beginning, or was it something which you stayed in a particular place for a long time?
It's hard to say because after that we moved to Canada for 5 years, and then I actually what I consider my second home is Zambia because that's where I did
Wow.
my high school, and then from Zambia I went to Hopkins.
Mhm, mhm,
So
mhm.
there's this moving around. I moved around a lot, and I think what it gave me most was a desire not to move around so much.
Okay, interesting.
It's-
Yeah. So, which also means that you actually not only have a pan-Indian culture, but also kind of almost international kind of exposure at a very early age. And it's very fascinating that you also spent some time in Zambia. Can you tell us, paint us a picture about how it was, if you recollect some time when you were studying there?
yeah, I went to the International School of Lusaka, which it was primarily for expatriates.
Mm,
A lot of
mm,
Americans. They had an American system and an English system. So I did my the English system, as Harry Potter people would know. I did my O levels, and but we did the different O levels. We did the O levels of from Cambridge directly,
mm, mm.
not the overseas ones. And and Zambia, it's at the time it was this was just before the copper crash.
Mm.
They're a resource rich country, and they're caught in the resource crunch, the resource trap. So a lot of the stuff was copper, and when copper crisis crashed, the economy tumbled, and it still has not fully recovered. So, but it was a much smaller country at the time, Now the population has, I think, more than doubled
Mhm.
in the 40 years since I was there. Probably,
So
probably
roughly, probably
more.
you were in 1970s during that time.
Yes,
Was it
in the early 70s.
early 70s?
Early 70s. I joined college in 77.
77. Okay, very interesting. So,
Yep.
which was there already an initial kind of inclination towards physics when you were studying there? How was it like? Were you already exposed to something very interesting during that time?
The first science books I remember were the ladybug books, ladybird books, ladybug, I think,
Mm, mm,
which were small books. I don't know if they still exist. I was told they do,
yeah,
but
yeah. Mm,
but those were there. And then I pretty much read everything, fiction, nonfiction,
mm,
whatever it was, anything from tanks of World War II to butterflies to planets. So I was interested in everything. The what when my parents, of course, like all Indian parents, they wanted me to do medicine. My father, especially, he was didn't have the opportunity to do medicine, didn't have the money to go into medical medicine, and but somehow I was not interested in that much. Even though I started biology in college, I turned out I was more interested in physics, just a natural evolution. It's possible that I would have been very much interested in the biology of today, which
mm.
the computational biology, for instance, it fascinates me, even though I don't know anything about it. But certainly, I didn't want to do wet labs.
Fascinating,
The
fascinating.
physics pretty fast.
Okay, okay. Now, this also means that you probably would have got exposed to mathematics along with physics. Do you recollect kind of influencing the education in mathematics influencing your interest in physics or the other way around?
Not really.
Because yeah.
I actually started in math in my high school
Hmm,
because I was always good in math. As you know, like many kids, I was good in all everything. So math and then we had additional math also, which was part of the O level curriculum. So I had a pretty good introduction even there. And then in college, I went through Taylor and Francis. I don't know if you know that old
yes, yes,
calculus book. So I went
yes.
through. I did every single problem in that one summer. I just sat and I did every problem in that. I don't remember any of it. I think perhaps it was a
Yeah.
wasted chance. These days, I do much more Monte Carlo work than actual mathematics.
Yeah, 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 because that's something which is very important. We're going to also go to that particular part of your research as we proceed into your contemporary aspects of the research. uh, so now you have kind of uh, some exposure to physics and mathematics. You also been studying at various different places now. So, how are you making up your mind to take science as a career? Is there any specific moment in your timeline which you find to be extremely vital in making the choice or a decision? If you recollect.
For me, it was pretty much just one step after the other. I don't think there was any choice but for me to go to college. And once I went into college, as I said, my parents wanted me to do medical, but that was never in the cards. And so it was just one. I decided to go get a PhD, science, because that's what I was interested in, physics. So it was always just one thing followed another. I stayed on at Hopkins for my PhD because of Space Telescope. The 1981 was when I got my bachelor's, and that's when Space Telescope was going to go to Hopkins. So I thought, here's a good opportunity to work with them. It didn't work that way because space is hard. So it was always just one thing followed another. I can't say
Nice.
that there's any step that led to anything.
Okay. So you probably would recollect the transition you made from Zambia to US. Like what was
Mhm.
your process of transition? from the place where you were living to the US. Probably you made this transition during your undergraduate days, right?
So we were in Zambia, and
Hmm.
uh, I was sick. I turned 16 the day I joined college, Labor
Wow.
Day of 1977. So it was a bit of a culture shock
Hmm.
because going to the U.S. at 16, you're exposed to the dormitories, and then at 17, I have my own place. So it was a culture shock. Took me probably a couple of years to really get over that. I don't think my grades were great the first couple of years. Uh, so yeah, it was a culture shock. I was the only Indian in the whole university. I mean, in
Wow, is it
the undergraduate body,
undergraduate?
graduate
Yeah,
student,
yeah.
but undergraduate, I was the only Indian. There was one other guy from Sri Lanka, but he was born and bred in the U.S. So it was a shock.
That
It,
is indeed a shock. Yes,
uh,
yes.
I look at it
Yeah.
now, and the university is very diverse.
Hmm.
I see a lot of undergraduates from India, which is a big change. That undergraduates can go to the U.S. And even and a lot of American Indians or Indian
Indians.
Americans rather.
Hmm. Yeah, yeah. It also probably kind of indicates towards some kind of economic, aspects also related to the Indian students going there to do undergraduate. It's still not an easy thing, right? Because
That's
it
right.
would probably,
That's
yeah,
right.
yeah, yeah. So one of the very fascinating aspect is that pretty early you probably also got introduced to astrophysics, uh, and you started a collaboration with Richard Henry, if I'm correct.
Hmm.
That's the person who you did your PhD with.
Right. Right.
And I have also kind of looked into some of the very fascinating things what Richard Henry has written, especially the mental universe and many interesting aspects
Hmm.
related to look at a way to look at the astrophysical picture and also bringing the physical picture along.
Yeah.
How was your experience, Jan? How did you get introduced to him? What was the kind of interaction you had? And of course, I'll be linking all the webpage links to both, of course, Giant's page
Mhm.
and also Henry's page. He writes a blog, a very fascinating blog.
Yeah, he does.
And yeah, he seems to be a very interesting person. Could you tell us how was your interaction? What was the kind of experience you had during your early PhD days?
So at the time, Hopkins was still a fairly small department, and if you wanted to do astronomy, there were only three people at the time. At the time when I was going for my PhD, a space telescope had been an option, but the people there they were too busy with the instrument itself, with the telescope and the building process. So we didn't have much contact with them. So there were only three people maybe. Yeah, yeah. When I was doing my PhD,
Mm.
so it was a small choice. You to pick one, and so I started off doing instrumentation. We were building an instrument for the space shuttle, and after that, my interaction with them it was very much in the classic American mold. You meet your advisor once when you go to meet him. You meet him once when you uh, once when you finish. You go to I'm sorry, I forgot the comprehensive. Once in the comprehensive, and then once when
Comprehensive?
you finish. So it was very much independent work, which
Nice.
I prefer. And I try to tell my students this also, because if you're planning to do a research career, then you do have to get used to solving your own problems.
True, true, very, very true. This is actually a very important point what you're making, especially related to the independence, and also some kind of an interaction with a senior colleague who might have had some greater exposure to the areas in which you're working on. So, what is the kind of problem you were thinking about during your PhD days? Like, was there a specific topic which was given to you, or you choose a specific topic? within the framework what Henry was working?
No, because this was instrumental group, largely instrumental and data analysis, there were two problems. One was we had IUE data, and that was my predecessor. He was graduating just at the time I was joining, so he handed me a stack of tapes. These were the old eight-track tapes.
Hmm.
So he handed me a stack of tapes and a stack of programs, and he said, "Go ahead, do whatever you want." And then he left. He had a postdoc at Goddard, and then we were doing the instrumental work also simultaneously. So this was to look at the UV background, and this had been a long-standing problem that this group had been working on. So there was not that much choice. You do what the group works on.
Hmm. Hmm.
And again, this is typical of the Hopkins group at the time. Maybe now there's more independence, but at the time you joined, there were always problems, many of them instrumental problems, and you would join at the beginning and go on through to the end.
Hopkins also has a very strong program in applied physics, and also a very famous medical school, of course, which is very reputed. Were you also kind of interacting with other kind of disciplines and other kind of schools within the university? Did you? How was your time then during the
We didn't
PhD?
go to the medical school at all. That
Mm-hmm.
was downtown, completely different campus. We're arts and
Oh, is it?
science,
Okay, okay.
and APL, the Applied Physics Lab.
Hmm.
That's largely a defense department establishment.
Oh,
In
is
fact,
it?
that's why it was set
Okay.
up so far away, because you're not allowed to do classified research on the Homewood campus. All classified research has to be done off campus. But I got to work with them a lot because we were doing spacecraft together.
Mm-hmm.
So we had some proposals. We were working on some big missions, and we had some proposals. So for a while, I had a joint appointment at APL, working with their astrophysics group.
Fascinating, fascinating. See, one of the crucial aspect, Jayant, what is very critical in space missions specifically, but generally speaking in physics, is the emphasis on instrumentation.
Mhm.
That is something sometimes which is lacking in the education, physics education in India, especially where that emphasis on hands-on training on systems and things which actually are deployed in a very specific environment. This kind of exposure is also unusual for anybody who does physics. So how did you learn things in terms of instrumentation and other things? Was it more of a culture in the lab, or you had a specific training program to really get trained in those things?
No, there was no training program. We of
Hmm.
course we had our labs, but the labs were not that useful.
Hmm.
More of it was just learning in the lab, learning by doing things. So we had a technical person
Hmm. Hmm.
and uh, and the previous graduate student. He stayed on as a postdoc. One of
Hmm.
them had left to go to Goddard, and the
Hmm.
other
Hmm.
one he stayed and for another 2 years. And he was in charge of the project, and I was working on it also. So that's how you learn.
Okay. So did you also visit Goddard during your
Is it
kind
what?
of the Goddard Space Station?
Oh,
The
many times,
many times.
because we were working with the International Ultraviolet Explorer
Nice,
(IUE),
nice.
and so in those days you actually went and observed. So
Mm.
we would go there to the control center. So yeah, I went there many times,
Wonderful,
and then I
wonderful.
was a
And
postdoc there also.
yeah. I'm going to come to that particular
Yeah,
point
yeah.
because before we switch to that part of your research, could you also give us a little bit more kind of some at least some details on the kind of instrumentation you were working on? Were you already thinking about the ultraviolet aspect of the problem, or was it a specific kind of module within the larger instrumentation what you were working on during your PhD?
No, in those days, Hopkins was known for the ultraviolet astronomy
Hmm.
program. Now, most of the people have retired, and they'll probably shut it down after one more person is there, Steve McCandless,
mm,
and after he retires, they'll probably just shut it down. They moved a lot towards submillimeter. They're doing Antarctic experiments for cosmology. But the UV program was really big at Hopkins. It started NASA in the '60s when
mm,
they were NASA has always had that science component,
mm,
and so they did two things in the '60s. One was X-rays, and one was UV. So X-rays, Giacconi was one of the pioneers, and he got the Nobel Prize for that. Later on, he was head of the Space Telescope. But Hopkins was big in UV astronomy.
mm,
And so people before me, we had experiments in Apollo Soyuz,
mm.
Apollo, and Bill Fasty, who you may know of the Ebert Fasty spectrograph, which is
Yeah, yeah.
yeah, a compact spectrograph. So it had been Hopkins had specialized in UV astronomy, and it was always in rocket missions. We,
Nice,
we had a
nice.
lot of rocket launches. But when I joined, there was the option to do space shuttle research
Mm,
because this was the time when NASA was trying to say that the space shuttle will do all science. They thought it would be cheap enough that you could go to space with the shuttle. No need for satellites or anything, just use the shuttle.
mm,
And so we were one of the prototype experiments for that. We were on what was called a getaway special, a gas can.
mm, mm, mm.
And we went there, we went on the shuttle, and we observed from that. So these were all smaller experiments, a few people. And so we had primary responsibility for the instrumentation, data analysis, design, instrumentation, data analysis, everything.
Was there anywhere in your mind that you could make a trip on space to space
No, I never
one day?
wanted to go I never wanted to go to space.
Okay,
And
okay.
in fact, in those days, and perhaps less so now, but in those
Mm,
days, going to space was a major disruption.
mm.
We had one of our astronauts, Sam Durrance, and he was a postdoc and research scientist at Hopkins.
Oh, is it?
But
Okay, nice.
but he
Mm.
was accepted for the training program for the Hopkins ultraviolet telescope, and really that took him away from research completely. He had to spend 3 years in Houston,
Mm, mm.
so it's too
Yeah,
much.
it's too much. Yeah, yeah. So, which also means that you are probably getting a flavor of some cutting edge uh, optics in the work what you're doing, especially related to the kind of optics which you use for instrumentation on space missions, is generally more compact, not the conventional free space optics what we generally use in the laboratories. So, what is the kind of training you got, or rather, what is the kind of education you actually had for yourself to get into that kind of topics? Were you studying some particular books or following some particular research? Could you just tell us a little bit about that?
No, again, really, it's just
Mm.
learning by doing.
Doing
So
okay.
the optics were the main thing was that it was all reflecting
Mm,
because
mm.
optics don't transmit in the UV.
UV,
The
yeah.
detectors were again pretty straightforward. We uh, we were using detectors that we'd used in the past,
Mm, mm,
and so there was nothing really. There was just things that you do. Of course, you make mistakes. So when I was calibrating an instrument, one time I forgot to bolt the lamp in properly, so it got sucked into the chamber and exploded.
oh my,
But it was
okay.
okay. They allowed you to make one mistake. Don't make the same mistake twice.
Nice. Okay.
So it
Okay,
was
great.
done as a student. It was done by graduate students, and they
Mm.
expected some amount of mistakes.
Very, very fascinating. Jan, do you think there is some kind of similar training programs or opportunities uh, for students in India to do this kind of work? Because majority of these kind of things are done in, of course, in ISRO and other kind of places. Probably nowadays also in some industries. Do you see anything like this kind of training, what you have kind of got in the past, been done in some, let's say, research universities or any kind of institutions in India? Do you think so?
Yeah, really, the only place we at IAA,
Mm,
we're the
mm,
only place that have really had a sustained emphasis on this. About 10, 15 years ago, we started this MTech program, MTech
mm,
PhD program with Calcutta. And the intent was always to develop students for instrumentation, for
mm,
astronomical instrumentation. And I've had five students get PhDs. One more
mm,
is finishing now. I've got two more in the pipeline. Other people have had students. Some of them are all of them well, some of them are working in TMT. Some of them
mm,
are working in other places. But we're the only place that has had a sustained training exercise for students.
mm,
Now, the
mm.
difficulty is that those students are having difficulty getting jobs in India. They're
Oh,
getting jobs outside. So, two of my students are in Austria. One student is in Australia. Another student has just joined Airbus in the UK, I believe. But when they apply for Indian jobs, they say all sorts of stuff. I mean, two of my students are married, so that's one issue.
yeah.
Another issue is that they're asking, why are you getting so many students from IAA? Because we have a unique program, uh, and so this is a serious issue.
Issue.
We're
Yeah.
producing students, and the students have done well. Not just my students, but the students from the program in general have done very well, just not in India.
Mm, mm. Yeah, because I should mention to the listeners that long ago I was a summer student at Indian Institute of Astrophysics. I had
Mm.
also, got to know Jayant, not very kind of in a very close way, but at least I had some exposure to Jayant's teaching and also some interesting lectures he gave as part of the summer research fellowship program at the Indian
Okay.
Institute of Astrophysics. And astrophysics actually and astronomy, astrophysics is the reason why I am doing research today. Because the
Mm.
fascination to the topic is still very prevalent. Just that I do optics. Maybe from telescopy to microscopy is how I actually ventured into. But I should mention that the kind of training what I got, even in that short time period of a couple of months,
Mhm.
spread over few more months, because I was in Bangalore, so I could go anytime. And I have been vastly benefited sitting in that fantastic library where there are so many interesting books. In
Yeah.
fact, I vividly recollect that, and also the library at Raman Research Institute. These are
Hmm.
the two places I cherish a lot. One of the interesting aspect is also that there's a very close kind of connection to observatories in Indian Institute of Astrophysics, which I'm going to come later on,
Hmm.
and I seek your input on that. But which also means that whenever you're doing research in astronomy and astrophysics, that close connection to observers is a very crucial part of it. In addition to, let's say, even if you're doing space-related missions, in Hopkins, were you also in connection? Were you interacting with people who are doing observations and other things?
No,
Uh,
not at all, because we
okay,
were doing space astronomy.
okay,
So,
okay.
yes, we had IUE observations, and later we had HST observations. But no, we never really interacted with.
Interact.
We didn't have any ground-based telescopes at the time.
Mm,
Later, we became part of the Sloan Digital Sky Survey.
mm, mm. Very nice, very nice. So next we're going to go in the chronological order, yeah, from your PhD times. So you're finishing up your stint at Johns Hopkins roughly around 87, if I'm correct.
Yes, 87.
Uh,
86
87,
was
and
when I finished. When I
yeah,
defended. 87 was my degree.
yeah. Tell us where you went and what you did. That is also a very interesting time. I believe. Please define that particular time.
Yeah, it was a very bad time to graduate because
Hmm.
the Challenger had just
Hmm.
exploded in
Expert, yeah,
'86,
yeah.
and so jobs went way down.
Hmm.
And many of the jobs I had applied for, they told me, no, we don't have the job anymore because we don't have any funding. I mean, the U.S. everything is funding related, So I stayed on at Hopkins for 1 year as a postdoc, and then I went to Goddard as a national, what was then a National Research Council postdoc. Now they call it something else. This was it was a competitive postdoc, and I joined what I joined Building 21, which was where IUE was. That was the ultraviolet part. And my advisor actually left just before I joined. So fortunately, I found another advisor, and we worked. So I was at Goddard for 2 years, but I didn't really like it because I don't really like the labs. I prefer the university environment. And so again, jobs really hadn't picked up by the time I finished. And so, but at Hopkins, there was an option. There was an opportunity to work on a proposal. So we were selected as one of the top two proposals by NASA. And so I was working on that, and then we weren't picked. But by that time, I was basically supporting myself for a while. I had a lot of
Oh,
money
wow.
from Voyager
Mm,
and from astronomy data projects. And then eventually I joined the Fuse project.
mm,
So for a while, I was funded by this Defense Department project, MSX.
mm,
So the infrared part is better known than the UV part.
mm,
But the idea was that this was part of Reagan's Star Wars. So the idea was that you would catch incoming nuclear missiles,
mm,
but most of the time they were not actually doing that. That most of the time they were doing nothing. So the PI Steve Price, he said, "Why
mm,
didn't you do astronomy in that time?"
mm.
So we had a good set of astronomy observations with MSX, and so that paid my
Wonderful.
salary for a fairly long time.
So, given that you also have a very strong inclination for teaching, which I'm going to
Mhm.
expand on at a later time, uh, during all these kind of formative years, were you also exposed to doing some teaching, or that is something which is only towards the later part of your career?
Yeah, at Hopkins, there wasn't that much of an opportunity
Mm, mm,
because they now when I went there, now a lot of the teaching is done by adjuncts, which I think is terrible, not by tenured track faculty. But at that time, when I was there, it was mostly tenured faculty teaching. So the only thing I did teach was the CTY program, the Center for Talented Youth,
mm,
and that's really expanded since then. It's run by Hopkins, but they
mm,
seem to have centers in many different places, and they do all sorts of stuff. But this was an excellent program. They got students from all over the world, and this was a concentrated 6 week, perhaps, course on astronomy. So I would teach every day for I think it was for maybe 6 weeks, and these were kids from 14 to 18.
mm,
So
mm,
that's about the only teaching I did there. Otherwise, not much of an opportunity. And I think I should have looked more. If I were
mm,
doing it again, I would have looked more at teaching at a teaching university. Hopkins, of course, was an R1, a
mm, mm,
top tier research university, where teaching was not really encouraged. But I should have gone to some of the other universities around and just volunteered
mm.
for teaching. And I never
Yeah,
really considered a teaching career. That might also have been interesting.
mm, mm. Yeah, but nevertheless, I know so many of this the people who have benefited from your teaching in India. So in that way, it's kind of it all kind of is made up in that sense.
I've
But
got about 10,000 students at least over
wow,
20 years, at least 10,000 students.
I tell that probably in the longer run, that is the most impactful thing one can do, as far
Perhaps.
as yeah, because of course research is fascinating, very important, but the kind of nonlinear impact you have
Mm.
when you're teaching is probably the greatest. In fact, even with whatever short experiences I have had, I can clearly see that there's a lot of benefit, not only to the person who is kind of getting the information or knowledge, but also the person who is actually disseminating it in that sense.
I'll tell you one anecdote,
Yeah, yeah,
which is
please, please.
a girl who was at
Mm,
Ayuka,
ah,
and,
mm,
they'd arranged this dinner with the visitor,
mm.
and she said that she had attended one of my lectures, and I had said then that I was started in biology and switched to physics, and she said that gave her the courage to switch herself. So you don't know what statements you make
Very-
have
yeah.
impacts.
In fact, coincidentally, I had a very kind of similar trajectory because a lot of stuff what I did even during my undergraduate studies, even in MSc level, because I did my MSc at Bangalore University, which had a
Hmm.
reasonably good kind of teachers and training in quantum
Still is
mechanics and
still is
yeah,
good. Yeah.
yeah, and also pretty good foundational training in some basic elements of experimental physics.
Yes.
And I was always interested in astronomy and astrophysics. I was interacting with also Professor G. Srinivasan at
Oh yeah.
Raman Institute.
Did he teach at
So
Bangalore University?
yeah, he did not. He did not teach at the university.
Yeah.
But we, some of us, used to go to his
You
course.
went to
There used
his.
to be the ISRO program led
Ah,
course.
yeah. Yeah.
Uh, I
Yeah.
was I was the first batch student in that,
I see.
in fact,
Okay.
and
Okay.
that really had a great impact on me,
Mm.
not only in learning science, but also getting a flavor of the history of science per
Yeah.
se. That's another thing. But what is important is that now going back to our chronological order of the
Yeah.
discussion, uh, when you're now getting kind of exposure to space missions right at the cutting edge level, right? Because
Hmm.
yeah, probably not only in terms of the science but also in terms of infrastructure,
Right.
there is an unprecedented kind of a facilitation of this particular thought process.
Hmm.
Having experienced that kind of exposure, w- uh, could you just give us a kind of a picture of how it was to spend time in NASA, not just only as a postdoc, but I'm talking about just as intellectual who is now looking at this, thinking about this in a slightly broader context, because space and space related research is fascinating, but also it has very deep connections to political programs and various different things related to how a country is looked on. Could you please give us a flavor of that kind of view?
So I was never on the big projects. I
Mm,
was never
mm,
on JWST or HST. We were I had a lot of IUE data.
mm,
I was
mm.
working. I knew the people in the IUE. Later on, when I went back to Hopkins, I was
So
working on
for our listeners, if you could expand the IUE, it would
yeah,
be good.
International Ultraviolet Explorer.
Explorer, yeah,
It was
international.
one of probably one of the until the Hubble Space Telescope, probably the most successful experiment in terms of publications.
Mm,
And so I was working with the people there.
mm,
And then when I went back to Hopkins again, it was not so much the cutting edge instrumentation. It was always ultraviolet instrumentation, and it was always smaller payloads. So not the huge payloads, but it was so the people there they were Goddard was really the science center,
mm,
and probably still is the science center for NASA. It's where most of the astronomers were. The other building had the gamma ray observers and the X-ray people. So,
mm,
but we
mm.
had the UV in my building, Building 21.
Nice, nice. I also, while looking at some of the papers what you've written, I also saw that you have some connections to single scattering and multiple scattering approaches to look at the interactions, especially in terms of the dust.
Yeah.
interactions and other things. Were you also working on such problems then, when you were looking at the UV part of the kind of interactions, or the dust part came later when you got interested in some other elements?
No, no, I was always working on this,
Ah,
but at that time computers were limited, and so we really couldn't do detailed Monte Carlo calculations.
calculations. Yeah.
So most of it was single scattering,
Mm, mm.
but it's so singles. But many areas the optical depth is low enough that single scattering is good enough.
Good enough. Yes.
So it's good enough physics, but pretty straightforward stuff. I didn't
Mm,
do any of this me scattering or anything like that.
mm, mm,
It was all very phenomenological.
mm,
This is the
mm.
albedo, this is
Yeah.
the phase function, and this is the scattering function. I didn't go into deriving the scattering function.
Function. Okay.
That was all
But
too complex for me.
nevertheless very important information, right? Because you would actually end up getting some very vital information of the interactions, and which might have implications in understanding how these wavelengths interact with medium and other things.
Yeah, it is a vital piece of the information. The difficulty has been that because you're working so close to the level of the noise,
Mm,
it's not been constraining enough.
mm,
So possibly the best data for dust, the best data come from extinction curves
mm,
and
mm,
modeling, not so much from the scattering observations that I do. But it's getting better and better.
mm, mm.
So we're getting to the limits.
But were you also doing some balloon based measurements during that
Not in the
time?
U.S., no.
Not in
That
the
we
US. Not
started
in
in India. Yeah.
India. Yeah, yeah. Yeah, we're going to come that
If you
to
can
that.
get to,
So
if you wanted to do that chronologically, we can do that. Or if you want me to,
yeah, yeah, yeah. Yeah,
okay,
I'm going to actually come to that particular point.
okay.
So, how long did you spend time in the Goddard, in the NASA
Yeah, I was
Goddard?
in Goddard for 2 years.
2 years.
It could have been a 3 year position, but 2 years was enough for me.
Okay.
Uh, and then I went to Hopkins again because of this
Again, yeah.
other missions.
Mm, mm,
So it was always, as I said, it was always just the things just worked out that way.
mm,
So I went back to Hopkins because there were UV missions, and I was the project scientist for the missions.
mm. So that UV mission actually had to do with something related to a space mission, or
Yeah, it
was
was a
it
space
part of
mission. It was
space
a
mission?
space
Okay.
mission.
Yeah.
We were one of the competitors to Galax,
Mm, mm.
and we went back and forth for 3, 4, 5 years, and NASA finally picked Galax.
Nice, nice. Okay. Yeah, well, but then was it a bit of a disappointment that the Galaxy took it?
Yeah, it was a big disappointment.
Yeah, yeah.
We, but it in some ways it worked out.
Mm,
I know the Galax people well. I've been working a lot with the data, so it worked out okay.
okay, okay.
It would have been nicer
So
to if we had our own mission, of course, but
yeah,
that's
yeah.
the way it goes.
So how long did you stay on that mission, the UV mission? Like you had a significant time period on that, or
Yeah, I was on
was it a?
Fuse until I was on Fuse for about 3, 4 years.
Oh, okay.
So after MSX, this BMDO mission, after the collapse of the Soviet Union, they
Mm,
suddenly
mm,
cut funding for this mission. So I had to scramble to find funding, and so that I joined Fuse.
mm.
I was working on the
I-
Fuse software, so a
Oh,
lot
okay.
of I've written much of the Fuse pipeline.
Very interesting. Very interesting. So during this particular time, are you already thinking about India, or is that at the back of your mind, or you're still stay put there, kind of doing the machine, and also contributing to Fuse and other projects?
Yeah, I had it in the back of my mind,
Mm,
and I was in
mm,
contact with people at ISC, TIFR, IA, IUCA. So I would
mm,
write every now and then, and it wasn't until about 1998 or 9 that really IA showed interest.
mm. mm,
because again, I mean, this is one of the things about Indian institutions: very slow.
mm,
They're not very interested in grabbing people.
mm, mm,
And so it was after Astrosat. Then
mm.
IA thought, okay, it's a good time to get someone who knows the UV. And so this
Chicken.
BB Srikantan
BB
played a
chicken.
role in that. Yeah.
Wow. Okay. Yeah. Because that's probably how the connection to balloons come. Then I assume,
No, not at
right?
all.
No, no,
Not at
not
all.
at all. Okay.
Not at all.
Okay. Okay. So then, please tell us this transition now that you're finishing or kind of doing your work at Hopkins, and
Yep.
you're on this particular project, and what was the kind of thing you were thinking about? Like, how would you? What was going on in your mind? Like continuing on this kind of machine, or coming back to India, or what are the crucial elements which was going in your thinking?
Yeah. So there's a few things that go on. One is, of course, that you feel that you make a greater societal contribution in India than the
Mm,
U.S. In the U.S., you know, I'm a pretty respectable scientist.
mm, mm.
Imposter syndrome and all that, you know. Okay, but I have a fairly good H index and all this.
Yes. Yeah. Yeah.
It's but it wouldn't stand out. So you go to the US, and even if you're a faculty member in a good place, you don't stand out.
Yes.
You are one of many. You're
Many.
there, you're not there. It makes no difference to the science in that country. So that was one idea. One idea was that I thought that I could make a real impact in India.
Nice.
Much smaller pond. Maybe I could make more of an
Mm,
impact. Another thing is that you don't have any permanent jobs in the U.S.
mm,
anymore. Again, you know, some people get lucky, some people don't. But ever since they took out the retirement age, the faculty positions have reduced.
mm.
And now, with this administrative growth in American universities, where administrators are running the colleges,
Yeah.
there's again less option for faculty.
Right.
So I had a couple of options. One was to join the SWIFT program. I was offered the project scientist position for SWIFT, a pretty big thing. SWIFT has been a pretty successful mission. And another was I was offered a position at IPAC, part of
Mm,
JPL.
mm, mm.
But I thought again, these are doing things that maybe I don't really want to do, and again, they're soft money positions. So you work for 20 years, and 20 years later, you're still on soft money.
Mm, mm.
So everything played a role. I
Very
don't know.
nice. Very
And Astrosat, it was a big thing.
big thing. Yeah.
India's first multi-wavelength experiment. So I thought it would be a good opportunity.
Fabulous. Fabulous. In fact, I'm very glad that you alluded to the point of contribution to a society, because uh, given the fact that I too have spent some time in the US, there are so many good people there, of course, but the kind of contribution one can do per capita actually would be smaller in that sense,
Mm,
because there are so many others who are also contributing to that.
right.
Whereas in India, if you take the same kind of expertise and enthusiasm, you would probably still you'll have probably even greater impact in terms of the numbers also, right?
Yep.
That is something, as
Yeah,
you
there's
clearly
certainly a lot of
mentioned.
opportunities. So a lot of
Yeah.
opportunities to interact with people.
People, precisely right, precisely. I'm very fascinating to hear that. In fact, that's an important point. Sometimes it gets kind of a less emphasis, because most of the time when people are looking at migrations on either side, this is not a point which probably is given emphasis on. And
Mm,
hopefully this also will encourage people who are making policy in India to to look at this as an important point, right? That's,
yeah. Yeah.
yeah, yeah. Yeah. So tell us about the transition, Jay. Like, how did you make it, and how was it? Because probably again you would have been undergoing another cultural shock.
So it was a tremendous cultural shock.
Yeah.
Fortunately, I came after, and I didn't consider this enough, but fortunately, I came after salaries had improved. So this was after the sixth pay commission. I think if
Six
I'd come
pay comes.
before the sixth pay commission, it would have been terrible. But I joined with the sixth pay commission, and that was that means that salaries are now okay.
Yeah. Yeah.
But what I thought was that there would be many of the names that you mentioned in your podcasts are people whom I've interacted with and have a much different opinion of. Let me
Okay.
not go into specifics, but
Yeah. Yeah. Yeah.
I found that there was not an inclination to
Mm,
learn different things.
mm,
And uh, one of the things was that I was used to, I mean, I'll tell you even little trivial things. One of
mm,
the things
mm,
in the US, you get used to the department shutting down at 5:30 because
mm,
everyone has to go pick up their kids.
mm,
Usually it's the spouses who have the more demanding jobs.
mm,
And so everyone has to pick up their kids at 5:30. And so the department emptied.
mm.
And in IA, they started meetings at 5:30. So I said, I'm not coming for any of these meetings. I'm not
Yeah.
coming for meetings in the evening. I'm not coming for meetings on Saturday. It's a 5 day week, and I'm going to stick to it.
Nice.
So that, and to be fair, that's now made an impact in the
Yes.
most things are they don't they're I think they're more family friendly now.
Absolutely. Absolutely. In fact, it's a very important point you're mentioning. Sorry to kind of interrupt. In fact, uh, things are slowly kind of dawning upon people
Mm.
that you will not be able to work effectively if you
Yeah,
create this kind of a constraints.
yeah.
uh, you know uh, it's actually I can totally relate to that, in the sense I don't have it as a direct experience as a faculty member, because
Mhm.
I came back later. But I could see that this kind of uh, very narrow thinking was very prevalent for a very long period of time.
Yeah,
Only in last, like, maybe 10, 15 years or so,
yeah.
especially with the exposure to the to the to the academic world, thanks to
Uh-huh.
even the information
Yes,
percolation, maybe this is happening. Yeah, please proceed. Please proceed. This
but
is a very important point what you mentioned. Yeah.
it actually has practical effects. So you
Mm,
look at
mm,
some place like ICER Trivandrum,
mm,
which is the way the hell out of nowhere.
mm,
And so you talk to the faculty there, they live in Trivandrum because jobs are in Trivandrum, the schools are in Trivandrum, and they have to go for travel for an hour and a half every day to go to the campus. And these are not these are not the decision, the place to put
mm.
academic centers is in the center of a city where you interact with the city.
Yeah. Yeah.
You not way off, isolate in an isolated place. And that I think the policymakers have not yet learned.
Mm.
So
Yeah,
so
in
that's
fact,
a practical effect.
you know vis-a-vis, if you take IAA, which is actually in the bang in the center of Korbaga, that's actually a good place. I can see that
No,
because
no, I'll get in
earlier.
trouble with people. I'll get in trouble with people because my grandmother would tell me, "Don't go to Kormangla, the
Yeah.
Koich."
Yes.
You know, Bapu had the choice. He could have put it where Nias is now.
Oh, is
He
it? Oh,
put
I
that
did not know that.
that land, and if he had gone there, it would have been a much different
Much.
institute. But
I can see that. I can see that.
he
Yes.
wanted to go there because it was isolated and his house was there. I mean, whatever. So just a mistake. Just a
Wow.
mistake.
If I'm just thinking, if it were to be in the place where Nias is, that would be
You'd have
right
yeah,
center.
RRI and
Yeah.
it would have been a great thing.
Great thing. Yes. Yes.
So this was one thing. Another thing that I found is that uh, people did not have one of the great advantages that we should have
Mm,
had in India is that we should have had much more freedom
mm,
because we were not. 20 years ago, we were not so much money driven. Uh, our salaries were guaranteed, students were guaranteed.
Yeah. Yeah.
So a small amount of money would have gone a long way. And yet, the people who were in charge of giving the money, and these are some of the names that you've talked about in the past,
Mm.
they were so infused with personal relations
Mm.
with-
Mm.
that they were they hurt the growth of at least science. I've told them, in fact,
Mm. Mm. Mm.
I've told them that, oh no, we're sorry, we didn't mean to do that. But the
Mm.
fact is that with more encouragement, with a little more risk taking, we could have been a lot further along. And so that was a culture shock to me also.
Mm.
US,
Mm.
everything is money driven, but once
Yeah.
you get the money, then people don't question you.
Yes.
You're
Yes.
you're, you're given the money, and then you're and when I was there, the money was fairly easy to get.
Mm.
Now,
Mm.
like everything, it's gotten harder. But
Harder.
when I
Yeah.
was there, it was fairly easy.
Mm.
And so you got the money, and then they asked you for the results at the end. And here it was just so much stuff put on.
Mm. Mm.
So that was another culture shock. Things like number of students.
Mm. Mm.
You can only have two students, so now it's more. But
Yeah.
yeah,
Yeah.
this
This actually, because to be very frank, even not now,
yeah,
even when I was a student, which is like 25 years ago, the enthusiasm to do astrophysics was at the level where you don't have any comparisons.
yeah, yeah,
Even today, even as teach my undergraduate kids, the maximum number of students are excited by astronomy and astrophysics.
yeah,
At least I'm talking about physics. you
absolutely.
know you could see if there's a public lecture either in Ayuka or in even in ISER or NCRA anywhere here, you will have houseful
Yep,
crowd.
yep,
That is, I mean, if that's a great indicator, right? Because where you should put your money. And I'm also generally perplexed why that doesn't happen. Yeah.
yep. Yeah, so I was so that was part of the problem. That to be fair, uh, the directors until one of our recent ones,
Mm,
they were all very encouraging,
mm,
and DST was quite encouraging. ISRO started out encouraging, and then got a little more. I started getting into trouble with with the panels, the
okay.
people who were in charge of the panel.
Mm,
They
mm,
let's just say that they were more personal than professional.
okay. Okay.
Uh, but in general, uh, there was an openness that I think
Mm,
is more difficult now.
mm. Nice, nice. So now you've kind of come back to India, and you're also settling down and also kind of trying to establish your own research. And how was your experience? What was good and what was not good while doing the science and really setting up the stuff whatever you wanted to do. As you already have mentioned, only two students. It's already a very constraining thing.
Yep.
Uh,
No, so the good thing was that I had absolute freedom.
okay.
I could, every institute has a culture, and
Mm,
IA
mm,
had that culture of openness
mm,
that you could do what you wanted. They as you know, I would teach at Bangalore University,
yeah. Yes.
and
Yes.
that is something that many places they might not. In principle, you're supposed to get the director's approval for everything.
Mm,
Our rules are based on the old TIFR rules,
mm, mm.
and you have to get, if you want to be on someone's exam panel, you have to get director's approval.
Oh, what? Okay, that's
Terrible, terrible, terribly.
it.
It's old British rules, and they would, and so I never had any problem. They knew that I would come in when I wanted. They knew that I would. They assumed that I had enough responsibility.
Mm, mm,
Not everyone did, of course. So the freedom can be misused. But in
yes.
my case,
Yes.
I found it very, very handy. The difficulty was in any of the large projects, and I don't know how
Mm,
much you want to get into this, but Astrosat I found to be a disaster,
mm,
uh, just because it got caught up in bureaucracy
mm.
and egos. So, but other than that, it was pretty straightforward. And
Yeah.
even students, you know, you get students have their own dynamic.
Mm, mm. True, true. Yeah. So you were already kind of into the astrosat machine then, right away when
I
when
was
you
one of
got
the
started.
PIs. I
Yeah,
was one
you
of
are one of the PIs because I'm also linking the proceedings volume of space telescopes and instrumentation. There
Yep.
are two nice articles where there's a lot of details on astrosat. So people who are interested can look up the
Yep.
references, which I'm going to anyway
Yep.
link in. But because I found this very nice kind of giving the overarching mission of the astrosat, and
Mhm.
also there is another article related to the UV mission particularly,
Mhm.
where you have
Yep.
also kind of written some very interesting stuff.
Yep.
So interested people can actually look into that part of it. So during this particular setting up process, and also now interacting with students, uh, one of the important things what you do and you have been doing is teaching. And before we come to that particular part of teaching, could you also tell us about the balloon experiments, and then we'll go to the teaching part of it?
Yeah, the balloon stuff started much later.
Oh, is
So
it okay? Okay.
yeah, so that started when we got our MTech students. I had
Mm,
a couple
mm,
of. I was pretty tired of the whole big project thing after
mm,
Astrosat, and then we had TAWEX, which was an
mm,
Indo-Israeli mission, which I probably would not do now. But anyway,
mm,
there was an Indo-Israeli mission, and that we were going to go as a secondary payload on GSAT-4.
mm, mm,
And what happened was that for various reasons, they we were kicked off of GSAT-4 because of a lack of weight. The
oh, okay.
they had in their last minute calculations, they decided that GSAT 4 was overweight. And so we were
Mm,
the easiest ones to take off. So they took us off. And then as it turned out, the mission exploded anyway.
yeah,
So
yeah.
good thing, bad thing, I don't know. But I was
Mm,
a little
mm,
tired of the big missions. And
mm,
so when we got our MTech program, I thought, okay, this is a good opportunity. Let's try something new. And so this is one of the things for which I actually can take credit is
mm,
that we started a new program of low cost space,
mm,
which
mm.
included the balloon program. We were
Nice.
developing instruments for low cost
Mm,
and stuff that was done by a single student. So if
nice.
you have the big missions like Astrosat, it just
Mm,
takes too long for students. You can't have students on it. No, they can't do their PhD. But these projects that we're doing, these are 2 3 year projects. So the student does everything from beginning to end, from initial project design to final calibration and alignment. Hopefully they get a launch at the end, but that doesn't always happen. But it doesn't
nice.
matter. They get their experience and then they go off and join some other program.
Program. Okay. So during this course of doing such kind of programs, especially
Hmm.
for students,
Yep.
uh, because of the fact that they are focused on one particular program,
Yep.
uh, the kind of transfer of expertise from one program to another program, how easy or difficult is it? Because
Yeah.
they
So
will probably also have to pick up something new and things
no,
like
this
that.
got to be a problem because there was a limit of 5 students.
Mm,
And
mm.
so I had 5 students. And so it wasn't until they graduated that I could get more. And so we
Okay.
did have a problem in transfer.
Oh,
Again,
okay.
one of those things in which the rules are there for a reason,
Mm.
but you know maybe you need to think a little and this is something that I think we have always had problems with in I'm going to say India, but certainly in
Mm,
astronomy. We don't
mm,
support. We have projects that go on as long as the PI is there, and then
mm.
once the PI goes, then these projects die off. You look at TIFR's X-ray program, for instance.
mm, mm,
At one time, they were world leaders,
mm.
and now they don't have an X-ray program anymore.
Yeah, that's
Of
a
course,
shame.
things
That's a
have
real
to
shame.
evolve. Things do have to
Yeah,
evolve.
yeah,
But if you make an effort, instead of hiring the quote unquote best person,
mm,
if you make an effort to hire people that you want to carry on programs, we might have a longer impact.
impact. Yeah, yeah.
So the balloon
Very.
program, the balloon program we started as a program to get experience doing
Mm,
space missions. At the time, I also thought that maybe we could do some science from balloons,
mm,
but it turns out that the program is too limited because we're
mm,
not doing the big balloons that TIFR does. TIFR does 200 kg, but we're
mm.
limited to 5 kg. And
Oh,
with
is it
5
okay?
kg, you have to do pointing and all of
Mm,
this. And it just turned out to be too limiting.
yeah.
So what we got, but what it did was it gave the students a good experience in just working with their hands.
Mm,
As you
mm,
said, that's often lacking,
mm,
even though these kids were electronics students and all that.
mm,
The balloon program, it teaches you fly something and you make a mistake.
mm.
So it teaches you that making mistakes is not fatal, but you do try to minimize the mistakes.
Minimize.
You don't have a chance to solve them. And we got to be pretty experienced. Now, mainly because of the weather, we haven't really had a good balloon program. The climate has been so messed up for the last 2 3 years. We just haven't had cloudless days to fly.
Nice. Yeah, you're right. Actually, that's an
Yeah.
interesting thing.
But then once they
Yeah.
got that, then they, except for the first one, Srijit, except
Mm,
for
mm,
Srijit, all of the others had space missions that they really did their PhD on. They continued to work on the balloon, but that
mm.
was a hobby thing. But these balloon programs are great for outreach.
Absolutely, absolutely. In fact, that's one of the main attraction of such kind of uh, physics experiments. If you look at that as a physics experiment, also,
Hmm.
it's
Hmm.
quite fascinating. So coming to the teaching part per se,
Yep.
to focus on that thing. In fact, I'm anyway, also linking some of the presentations and also some of the things what is there on your webpage,
Yep.
which I would strongly urge all of you to go and check. There's a very fascinating kind of
Hmm.
you know list of presentations which Jayant has put up including, if somebody is interested, one can also look at, history of astronomy and those kind of topics.
Yeah,
And it's very
I need to
fascinating.
update it, of course, but yeah,
Yeah, yeah, it's there because the content is there. You can surely
the
go and
content,
read and
content.
understand. So then, one of the crucial elements, and also seeing so many students whom you have kind of trained and taught, and also you interact extensively with so many students. Uh, First and the most important question is, why do you do that? Please tell that, because it will be very good to hear that. Why at all you do that? Because you can easily not do that, because like many other people, you could
That's right.
actually just sit and do something. And
That's right.
second thing is, how do you do that? That is important for people who are also enthusiastic to do these kind of things. So please tell the why and the how of kind of,
Yeah.
a broader level teaching. It need not be only just the graduate level teaching, which is very important for all of us. We can learn more from that particular thing.
I actually enjoy I don't enjoy the more pedantic courses as much. So I don't like courses with that much math, and because I'm a slow thinker on the board, I tend to think more intuitively. The Feynman story where he explains, someone explains a problem to him, and he says, "I didn't understand anything you said, but
Anything?
I know that a blue ball is not a red square."
Yes, yes, yes. It's there in his. Surely you must be joking,
Yes,
Mr. Feynman.
that's right.
Yes, yes,
So that's
yes.
the
Yeah,
kind of stuff I that's my strength. Not to
nice.
the level that Feynman has, of course,
Mm,
but I can understand the logic of things, the
mm,
physics of things more than the detailed mathematics.
mm,
And And so I enjoyed teaching the undergraduate courses. And how I got into it, I was this is one of those things that's always difficult in India, because in our research institutions, because there's no push. I've
Mm,
always felt that it is part of my mandate. We are scientists. The science doesn't help anyone if it sits with us. We have to tell people what we're doing, and hopefully, some of these students will go on to become scientists. Some of them may go on to become taxpayers. Someone asks them, why is it important to do science? They'll say, oh, it's exciting. There's that selfish urge also. How I got involved with it took a long time. It took several years, 3, 4, 5 years, and I let's see. Part of it, one of it was a fortunate thing. GST Babu started
mm,
this thing at Bharatiya Vidya Bhavan,
mm,
which the Birla Institute of Fundamental Research. So he started that. He was my colleague, and he
mm,
knew that I liked to give lectures, so he invited me there. So that was there. Vishu got me into teaching at the planetarium, I believe.
mm. Nice.
And so once I started teaching at the planetarium and there, then from there I went to Bangalore University.
Mm,
I got onto the REAP program pretty early at the planetarium. Maybe that was through Vishu and Madhusudan and Shailaja.
yeah,
So
Shailaja.
through
Yeah.
all of them, I got into the REAP program. And then after that, I started people got to know that I would give lectures around. So I gave a fair number of lectures at colleges,
Mm.
but these are one-offs. For the colleges, it helps that many of the colleges I got introduced through the Bangalore University program,
Yes. Program.
because
Yeah.
they were running these programs for teachers, these certificate programs,
Mm,
and so
mm,
many of the teachers would come to hear me there,
mm,
and
mm.
so then they would ask me, "Can you give a talk at our
Oh,
college?"
oh.
And of course, they would get points for it for UGC.
Mm,
So it helped them.
fine.
So I got to teach at a fair number of colleges there. St. Joseph's, I got in through that space program,
Space program. Yeah. Yeah.
that thing, the one that Srini was in charge of for a
Yes.
while,
Yes.
Srini
Yes. Yeah.
Vetrikumar. So I was lecturing there. I knew Rabbi
Mm,
quite well at St. Joseph's,
mm,
and
mm,
so I got to teaching there.
mm,
Christ, I got to teach because of Gudenauer,
mm,
who was then in the physics department. We were in an astrosat workshop together, and there they encouraged us to put in astrosat proposals. And this is something that, again, I thought was done very poorly. That
mm,
we were not doing. Say, astrosat. One of the major reasons, again, air quotes, to do astrosat was the fact that it would build astronomy in the country, and we really didn't do that much of it. So, but they did have this program where there were astrosat related proposals, and
mm.
so I did that with Goodenauer, and he and I we really did start the astronomy program in Christ University. That's
Yeah.
now doing quite well.
Quite well. Quite well. Yes.
Well,
Yes.
quite a lot of students, but we had the first students there, and those students have done well
Mm, mm,
also. So there, and then once I was in the Christ system, so to speak, then they asked me to do some master's courses, and
mm.
I also did a certificate course in Christ,
Yes.
where I don't quite know what the students got out of it. I think they got some credits at the
Mm,
end. It was not really worth my time. They paid me some, I don't know, for 3 months of work, they paid me 10,000 rupees or
mm.
something. All of these have been voluntary. Bangalore
Voluntary. Yes.
University, when I was teaching, they'd give me 100 rupees, which wouldn't even pay for my petrol.
I know, I know you. I vividly remember you used to drive from
I used to drive.
Kormangla to the, yes, yes,
I would
because
drive. Yeah,
yes, yes,
yeah,
Kagli used to, probably Professor Kagli used to coordinate and do something. I suppose I don't recollect who his name
yeah, yeah.
was.
No, I would drive from my home.
Oh my
So,
word.
yeah.
Yeah.
And I would
Yeah. No.
spend the afternoon in Bangalore University. Those were the
Yes.
days when you didn't have good toilets there.
Oh man.
Now it's
Yes.
better, of course. Now it's better.
Yeah.
But so
Yeah.
then university, and then
Mm,
then from there, I guess I was well enough known. So I think many people have now know me in the Bangalore college
mm,
circuit.
mm,
Some of them have been my students
mm,
in various things, uh, perhaps from Christ or perhaps St. Joseph's. So they've been my students, so they know me. So now, what? So now almost pushed my way into the planetarium. I taught a course in data analysis.
mm.
I volunteered to teach, and they were happy to do it. And at St. Joseph's, again, I'm teaching data analysis, and I'm teaching a course at NMKRV College,
Wow. Okay.
which I'm actually very proud of
It's
because
a
this
women's
is
college, right?
women's
It's a
college.
women's college. Yes.
Women's
Yes.
college, but this is a class that they advertised. There's J. Ramkrishna at
Mm,
from ISC. He's running
mm,
trying some educational thing, and so he asked me to give a class on astronomy. And this is purely voluntary.
mm.
I don't know how much the students are paying. I don't know if they're paying me at all,
Okay.
but whatever. So I go there once. This is something they're doing after college.
Nice.
And
Nice.
some of the students are coming directly from college. The college is not even giving them time off to attend. So this class starts at 2:30. They come at 3 because the college is not giving them time off.
Fine.
And I have 100 students.
Wow.
And they're
100.
staying for the class. I've done it for 12 classes so far. I'll do it for another month. But 100 students who are coming to every class. So this I'm actually quite proud of.
Fabulous.
Okay.
Fabulous. Fabulous. That's something, Jayant, it doesn't get appreciated in our society, right?
It does not.
Because see, uh, first and foremost is the person and the enthusiasm who is ready to actually share their knowledge. Second part is also the perception of how knowledge impacts the society is also
Mhm.
something
Yeah.
which is not appreciated, because in the age where YouTube channels and even podcasts actually are dime a dozen, so to
Yeah.
speak, somehow this part of direct kind of interaction between human beings
Hmm.
is somehow undervalued, because
Yes.
I pandemic was a great lesson for all of us, right? Because you could
Mhm.
see that the effectiveness of education only through a screen is very inefficient.
Yeah.
In fact, this is something I'm very glad to hear this. In fact, again, if somebody who is up there as a policymaker listening to
I
this,
know. I know.
please pay attention to this particular
But
point.
I'll tell you the counter example,
Yeah, yeah,
which is
please,
that
please. Yeah.
a couple of weeks ago, some kids in Nairobi contacted
Mm.
me. Not the kids, but the mother contacted me and said, "Can you give a session to my kids?"
Wow,
I did
wonderful.
that, and I've done it in not Dubai, in one of those places, Abu Dhabi, maybe Doha.
Mm,
I've done
mm,
that a couple of times. Some kids in a school there, Pakistan,
mm,
in
mm,
some kids in Indonesia.
mm. That's
So this is
fabulous.
also
Yeah,
the
yeah. In fact, wherever the technology can be deployed, it should be.
yeah.
I totally agree with you.
Some
I see
kids
the
in
point
Pune,
what you're
they
making.
just called up. The mother
Yeah,
called up and said, "My kids are interested in astronomy. Can you give us Can you talk to us about astronomy?" So
nice. Fabulous, fabulous, fabulous. This is something which is that happens only because a person is ready to do that. Because I think there is a kind of a slight amount of privilege which is there in among academics, which can be utilized.
oh, terrible.
It
Yeah,
is right, because
yeah,
if it only takes just some kind of willingness for
yeah.
somebody to do this, and I'm
Yes,
very glad. It's a kind of very inspiring thing for a lot of us who, I'm hoping if somebody is also listening to this, would take this as a part of the motivation. Fabulous, fabulous. So on the same lines, Jayant, there was a very nice interview in
yeah.
Bengaluru, where It was dated March 27th, so it's quite recent,
Yeah, pretty.
2024.
Yeah,
Yeah, pretty. There's a very fabulous interview of yours, and the title is quote, "Our world is built on basic science,
yeah,
and part of basic science is rationality." Stop quote. I really enjoyed this particular interview, especially the emphasis what you're putting on rationality without sounding condescending. That is something which is very very critical in a society like India, because I am very strong proponent of rational and critical thinking.
yes.
But sometimes I feel that we may actually not be doing it right, especially people
Mhm.
who would want to do it. Because one of the statement which was very impressive is that you mentioned that you still can ask your student to do whatever they want, but you have to question that aspect of it.
Yeah.
Could you please elaborate on this? This is a fabulous kind of point which has to be emphasized a lot more. And if you could just elaborate on things, and we'll also take the discussion a little broader on that.
So one of the things that I do in all of my talks is I say I try to keep it tied to real life
Mm,
in some ways. So I bring up women's issues, I bring up climate change, and I bring up rationality.
mm,
So I do say that one of the things that I try to say is that why are we doing science at all? And so I bring in that economic argument,
mm,
which is that it's no accident that Bangalore is the science capital of India.
mm,
It's because of ISC and
mm,
because of the engineering colleges that
mm.
grew up
Comes-
in.
yeah.
I mean, we all
Yes,
talk bad about the engineering colleges, but nevertheless, it's given that group of people and that is why that's why Silicon Valley is Silicon Valley because of Stanford. Uh,
Stanford. Yes,
so all of these, so that's the practical thing that when you spend money on science, it feeds back into society and it really improves the it improves your life materially. So that's one thing I say. Well, then I
yes.
talk about science as rationality,
Mm,
and I point out civic issues. Things like we all know this. We all know flyovers that are built for whatever reason.
mm,
You look at the
mm.
flyover. Why is there a flyover here? There's 10 cars that go through here an hour. Why are you building a flyover? Yeah, I'm taking an extreme
Yes, yeah.
exaggerating, but nevertheless, we know this. We know that there's lots of we're facing this in Bangalore now. Why are we facing this water crisis? It's
Mm,
because
mm,
of irrational growth. And so I say that one of the reasons we teach science is because there is a cause and effect. If I take this microphone and I drop it, it falls, and so there is a cause and effect, and then I tie that into your daily lives. I always come down hard on astrology,
mm,
and
mm,
that hasn't got me into trouble yet,
mm.
but I do. I say that there's no point in looking. The stars don't care what we do. Why are we going to
Exactly.
the stars? But
In fact, sorry to interrupt. In fact, in your lecture notes, one of the places I saw this beautiful, you know, discrimination between astronomy, astrophysics, and astrology. In
yeah,
fact, that's a very nicely made thing, because a
yeah,
lot of times it gets kind of intermingled.
yes,
Of course, historically there is some progression, and you also mentioned that
yeah,
how it actually progressed from one to
yes.
another. In fact, I'm linking that part of it also. The
Okay.
listeners can actually go and look up. Yeah, please proceed. Please proceed.
No, so just to get to
Yeah,
what you said, one of the things
yeah.
I say about astrology
Mm,
is, when the Venus transit was there,
mm.
a lot of these astrologers were trying to say that it's an eclipse. And I said, I think I was on TV9 then.
Okay, okay.
There was an astrologer next to me. He was
Okay.
he was very upset at me. He said modern scientists are not a patch on ancient scientists. But I said that they didn't even know about astrology is built on the past. It's
Yes,
not built on new things. There's
yes.
no change in astrology, and so for them to take this Venus stuff and try to shoehorn it
Sure.
into, well, they didn't even know about Venus crossing the sun, and so that's one of the things I said. Uh,
Yeah.
but so this is what I bring in about rationality. I say that there's a
Yeah.
cause and effect, and no matter what you do, whether you pray or whatever you choose to do with your time, at least think about it. And that I think is that I think people understand. Of course, I talk a lot to younger
Mm,
kids,
mm, mm.
to college kids, and college kids are perhaps less set in their ways.
Okay, yeah, you're right. But
I'm talking to
one
my little RW8 this evening, so we'll see what what they say.
Wow, nice, nice. Now, one of the things you see, the points what you raised in that interview is very important. In fact, I'm linking that particular interview in
Yep.
the notes. Also, listeners can look into it. One of the things is you also mentioned that the the rationale behind doing science outreach is not only to just educate, because it goes beyond the kind of
Yep.
conventional call of duty, so to speak.
Yep.
And in what way can we kind of encourage society to have a broader base in science? Because I think that is probably one of the lacking aspects. For example, people it's not part of our cultural, conventional
Yep.
conversations. It's not even, for example, a conversation on a dining table where the family is sitting many a times. How should we penetrate that part of it? This is actually a positive penetration into the society.
Yeah.
What are your thoughts, Jayant? How should we go about thinking on those lines?
Yeah. It's something that clearly we've not succeeded.
Hmm, hmm,
We need to again, I always point out cell phones.
hmm,
Cell
hmm,
phones, they won't work without relativity.
hmm. Yes, yeah,
You
yeah.
you need basic
GPS.
science. You drive your
Hmm,
car. I can't fix a car, but I know how a car works, and this is not part of our culture. And
absolutely
why,
right.
I don't know. I don't know why it's not. One of we need to take the opportunities we have, and many times it's taken the wrong way. People take this opportunity, and then they say, oh yes, I got my faith from whatever, I got my inspiration from whatever.
Hmm, hmm, hmm.
But this asteroid business, it's captured many people's imagination. It's like, the 3 day wonder thing.
Yes, yes.
And so all we can do is seize these opportunities, and make the most of it. And as you say, you have to talk to people, and it is hard, you not to be condescending, because
Hmm.
people take anything you say, they misunderstand what you say.
What do you say? Yeah. So one of the other elements which is very vital in this kind of communication is that science should also not be only in a particular language, right? That is another aspect which probably has to change in our culture,
Mhm.
where vernacular languages should actually take it and run. The sciences should be now be one of the important aspects of conversation in all languages.
Yeah.
Unfortunately, only the English aspect actually is emphasized. Somehow, if that part of translation of a lot of books can happen now with the emergence of AI based technologies, probably one of the good uses hopefully would be to do this, where there can be some kind of mass translations which can happen. It can be even some speech translations in case there is sufficient kind of expertise coming out of it. What do you think about it? Do you think there is scope for improvement there in that part of the communication, the science communication aspect of it?
So, certainly, unfortunately, for professionals, you have to know English,
Yeah, you're
and
right.
there's no question that students. It is. We put too much of a burden on the students. They have to be good at speaking. They have to be good at writing. They have to be good at doing the research. They have to know English. When they get older, they have to be able to write proposals.
Yeah,
They
yeah.
and the government puts a mandate on us that we have to do outreach. It's
Outreach.
a
Yeah,
it's a heavy burden for
mm,
students,
yeah, yeah,
and not even for students. As you know,
yeah,
many of our colleagues cannot speak to people.
yeah, yeah. You're right. You're right.
No reflection on them at all.
Yeah.
They're good at what they do, but it's not necessarily the same set of skills.
Absolutely correct. Absolutely correct. Yeah. Yeah,
And
because
so, yeah, sorry, go
because
ahead.
yeah, there is also a kind of criticism, especially if you look at the people who are outside academia. They
Yeah,
also think that we are too insular.
yes,
In Yeah, even if somebody is very articulate, they may
yeah,
not want to actually communicate with the outside world
yeah.
because they think that it's not necessary or something like
Yeah, no, no, I will fully admit to having that problem.
that.
I don't know, I don't watch much Bollywood.
Same here.
I'm a cricket fan, so I have difficulty in casual conversation. I fully
Yeah,
admit to that.
yeah.
And so yes, it is a problem. So to what you were saying about languages, I think that it is
Mm,
very
mm.
important that we do communicate in language in different languages to people. As you know, Tagore
Yeah.
was had that big thing about very beautifully written. Of course, I read it in English, but very beautifully written thing about how he learnt in Bengali.
Yes.
And if you remember his description of row, row, row your boat,
Vote.
he,
Yes,
he didn't
I've
know
heard.
what it was. And unfortunately, my language is English.
Mm, mm.
It's my family language. You know, we're one of these many threads in India.
Mm.
And my grandfather and my mother, even though my mother, you probably know she was a Kannada writer, and
Yes.
yeah, and she
Yeah.
wrote books
Could you
in Kannada.
please could you please tell about her, because just few words, Jen, that would be great
Sure,
for our audience. Yeah. Yeah. Please.
sure.
Please.
So my mother, she was one of the first women students in ISC, and she was. If you look at the
Please
photograph,
tell her full name, because our
uh,
audience would know her.
yeah, her name was is Nalini Murthy.
Nalini Murthy. Yes.
Nalini
She is
Murthy.
actually she was at least a household name in
She was.
Karnataka, in
She was. She used
Bangalore.
to
Yeah.
write a lot for Sudha
Sudha.
and
Sudha. Yes. Yeah.
Lovely, and yes. But so as I was saying, she was one of the only women students in ISC. I think the only woman student in the electrical engineering department. But her teacher was, we call her Mrs. Chatterjee. She was a family friend,
Mm.
but actually she was Professor Chatterjee. She was a wonderful woman. She went to
Mm.
Michigan to do her PhD in before the war, and she was, I think she had was on a funded on a government of India
Yeah.
uh, s- thing. But we knew her family. Her family and my family had known each other since the 30s.
Yes. Yes.
She went to a her teacher in school was my grandfather's brother.
Wow.
Actually, my great grandfather's brother. But anyway, so my mother was one of the first students there, and then she when they moved to Canada, when my parents moved to Canada, she got her master's from Manchester, and then when they moved to Canada, she was the first woman PhD in Nova Scotia,
Wow. Yeah.
and so she was always communications engineering. And so, but I don't think I got my interest in science from her really,
Mhm.
for whatever reason. She was a well-known Kannada writer, as was her aunt, HV Savitri, HV
Savitri. Yes.
Savitramma. Yeah, so
Savitri. Yes.
so uh, she wrote a lot of books, and she had a lot more planned. And she died young. She died at
Mm,
54,
mm.
but she was one of the first people to write science books in Canada.
Yes. Yes. In fact, I should mention, since you're mentioning, Dr. Nalini Murthy also has written a book called Sahitya Vignana Sankirana.
Yeah,
There is a very, very beautiful book. It's actually, I'll be anyway linking some of the things, to at least the references. People should have a look at it. There's also something called Pratigne, which is actually very well known,
yeah, yeah.
her book.
That's right.
And yeah, I mean, it's great, great. It's a fabulous, I'm so delighted to actually,
Yeah, but
hear
she
this.
used to communicate with her father in English.
Wow. Nice,
And
nice.
and an even funnier story,
uh,
her grandfather was H.P. Nanjandaya, and he was one
yes.
of the founders of the Kannada Sahitya Parishad.
Parishad. Yes,
But he
yes.
gave the founding lecture in English.
That's true. That's true. Uh, Very interesting. Very interesting. Now, if I understand correctly, even probably you are Anantmurthy was a professor of English. but wrote in Kannada.
Yes,
It's
probably,
yeah,
probably.
yeah. Yeah, it's very fabulous, fabulous. No, because that rich tradition of literature is
Yeah,
so part of that. I'm so glad, that unfortunately people don't give emphasis to people who do it in local languages. And there are some fabulous things. You look at even Purna Chandra Tejasvi and other people who've
yeah,
written some very good stuff on rationality. Kuempu, of course,
yeah,
and other things.
yeah,
Great to know this, Jen. I'm so glad to hear about this. It's very
yeah.
fabulous. Yeah.
So even though I've written articles for the Kannada books, Nava Karnataka, for instance, this
Yes, yes.
one,
Yeah.
Shailaja was kind enough to translate.
Translate,
I
translate.
cannot do it in Kannada.
But you
Conversational,
speak.
okay.
Uh,
No, I don't. I cannot. I manage okay on the streets.
mm,
At
mm.
home, we speak a bastardized version of Telugu.
Oh,
Even that, in my family, for 5 generations, it's been English.
English. Yeah, yeah,
Yeah,
yeah. Fair enough. Fair enough. See, that's actually one of the beauties about living in India, right?
yeah,
Because you will still be an amalgamation of cultures,
yeah,
and that's probably one of the most beautiful aspect of a life in India.
yeah,
In fact, sometimes we don't appreciate because we are deeply embedded in the system. Because for example, I am in a Kannadiga living in Pune,
yeah.
and my own daughter is now learning Marathi, and I'm
Marathi.
learning bit of it from her and other things.
Yes, yes,
Yeah,
right,
yeah,
right,
yeah,
right.
it's a deeper connection to that. Yeah.
Yes.
So we're going to actually probably also expand a little bit more before we come to the closing. And a couple of things I want to ask is your general kind of overview of looking at uh, two things. One is astronomy and astrophysics as an area of research. Uh, kind of what are the new frontiers, new directions in which a lot of exciting things are happening. And second thing is your own broader perspective of where is science and technology proceeding, both in terms of Indian context and in a slightly more broader, world context. If you could just, because I know that you have very interesting thoughts. I'd be very happy to hear that and your thought process on that.
So my great fear is that we're selling out to the to the billionaires,
Mm,
and in that government is in many ways withdrawing from science. And this is
mm,
true to a fairly large extent in India, where I think the neoliberals have
mm,
neocons, neoliberals, whichever,
mm,
have taken over. And so, for instance, the new space policy, as I
mm,
said in that Hindu interview, they want a lot of money, or the new education
mm,
policy, they
mm,
want a
mm,
lot of money to come from private people.
mm,
And I
mm.
think there's nothing wrong in private institutions. I'm all in favor of Ashoka. I'm all. I think Azim Premji has done great work.
Yeah.
Shiv Nadar,
Mm,
uh, in many of the engineering colleges, I'm not so much in happy with. They're
mm,
because they're interested more in a marketplace situation where education is not part of the equation. Degrees are the equation.
Degrees are there. Very nicely put. Yes.
So, so I'm worried about that, and I'm worried about ceding science to things that multi-billionaires find fascinating. Things like alien life. You lose the basic science, and when I say science, I'm including things like historical research,
Mm, mm.
uh, things that are humanities research in general.
Absolutely.
That,
Absolutely
that
correct.
these are all things that should be done with some level of academic freedom.
Mm,
And yes, it's always good to be responsible. Yes, you have to show what you're doing, but you have to be free to work on what you want also. And this I find to be concerning. Again, not just in India. I think this is a worldwide phenomenon. And the science itself, I think we're now at a place where we understand science, we understand the world, but yet there are so many things that are hidden under the carpet that we don't know. Dark matter, for
mm,
example, from
mm.
astronomy. What is dark matter? Why aren't we finding it? The Sabine Hossenfelder keeps talking
Mm,
about this. Why aren't we
mm.
finding it? So there are a lot of things that are hidden, and but we do know the world. We know how the world works.
Mm, mm.
I doubt that there are going to be any of the major surprises that there were, in Oppenheimer's time.
True, true. Very nice. Very, very important viewpoints what you mentioned. So, is there also a room for science and society getting closer? Because sometimes it still is kind of detached a little bit. And outreach is one of the efforts what
Mhm.
you are personally involved. But is there a room for somehow society to also look up to science in a slightly different way? Because there is also generally a slight kind of confusion between science and translational technology, which is
Yep.
important. I'm no way demeaning that or
Yep.
I'm taking it down. But somehow, the fact that the continuum is not appreciated sometimes, and it leads to a lot of confusion. And partly also, that element of wonder and also the curiosity is somehow looked down upon as something only something you should do it as a pleasure, which is actually exactly the other way around, I suppose, right? Because the human tendency is first to become curious and then do everything else.
So there's a lot in what you said, a lot to unpack.
Hmm,
One is, of course, the confusion between technology and science. That basic science is not technology, nor does it lead to technology.
hmm,
Our job in our academic institutions is not to make your life better. Our job is to set the environment that other people come in, they learn.
hmm.
Facebook
Yes.
came out of Harvard. Google came out of Stanford. So we
Exactly.
set that environment where people are encouraged to think
Hmm,
and go abroad and do new things. So that is our goal, not the technology. Ratan Tata had gone to ISC and said, "Why aren't you guys building me a better car?" That's not the job of ISC, and you're
yes.
wasting ISC's worth if that's what you think is important.
Exactly.
Or I mean, many times the government asks, they tell IIT, "Why didn't you come out with some thing to build a inter-river
Hmm,
linking?" These are important, but it's not
hmm,
necessarily part of the. You can't take a professor of astronomy and
hmm.
tell them to work on river linking. It just
True.
is a waste of everyone's talent.
Yeah.
So that's one thing: the confusion between technology and science. The second thing is, which I think is more worrying. I think there is an awful lot of resources out there at different levels, different styles to appeal to everyone. What you're doing is very important. There's many other YouTube channels, many podcasts. Uh,
Yeah.
I listen to a lot of podcasts,
Mm, mm.
mostly history and space,
Nice, nice.
and I learn a lot from them.
Mm,
So a lot of podcasts out there, but the danger is that there's a lot of bad stuff out there too.
mm,
And a lot of these godmen, they speak very
mm.
nicely, they
Yeah.
very fluently. I don't know if you want me to mention them, but it's okay. So
Yeah,
they speak
yeah.
very fluently, and yet they're speaking nonsense.
Absolutely, absolutely.
And
I
how do you
agree with
tell the difference? And again, this was always my problem. This is another thing that I would tell my students.
you.
Whenever I was on TV with an astrologer,
Mm.
which happened more times than I would like
Oh man.
to
Okay.
remember, but
Mm,
the astrologer would come with a stack of papers,
mhm.
scientific papers. This shows this. This shows this, and all I'm armed with is the truth.
Yeah. That's
They
very
can lie. And convincing lies are so easy. I had to block someone because he kept broadcasting COVID nonsense on me.
oh man. Okay.
You know, it's something COVID was perhaps a poor. It perhaps set us back in many ways.
Mm, mm,
Vaccines were great, and vaccines science and all that, but then you get, as you will always get, the caveats.
Caveats. Yeah.
People who get the vaccine and still get COVID,
Mm, mm.
or the long COVID.
Long COVID. Yeah.
You're unable to, was it the right thing to do
Mm,
to have a lockdown? You
mm.
can argue about this. Is all part of the scientific process.
Yeah.
As
Absolutely.
it happens, and you make the decisions based on what you know at the time.
Time. Yeah.
When you look at it a year later, maybe you would have made different decisions. I mean, we all do
Exactly.
that in our lives.
Yeah.
We
Yeah.
can look at
Hindsight.
hindsight. I would have made a different
Mm,
decision then, and that they make such convincing arguments, and it may treat people to distrust science. And I don't know how we handle that.
yeah.
I tell people I always tell the truth. That's how.
Mm. That's a
If I
good
don't
good
tell the
way of
truth,
actually.
then I'm not a scientist.
Fabulous, fabulous. So before we also kind of come to the conclusion, one very interesting thing which has now evolved is the naming of the asteroid. Asteroid
Okay.
Giant would think it's a great honor to actually have that, because we are also very happy. These are the kind of recognitions we should really celebrate.
Yeah.
Not only because it is something related to India, but you can see that how science also has humanizing element of it. Could you please tell us a little bit about that, Jayant? A kind of a
Sure.
flavor of how this has happened. And I know that your contribution to UV, specific aspects of it has been highly appreciated even before the asteroid were actually named. People should know about that very particularly. But this is actually a good thing. Yeah, that's the reason.
Yeah. So it's more of a public relations
Yeah,
bonanza than anything else.
yeah, yeah.
The way it happened is that asteroids are detected, are found all the time. They're automated searches for
Mm,
asteroids. And Mark Bowie, who is a scientist who
mm,
I think I've met him once or
mm,
twice. Anyway, he's found a bunch of these asteroids,
mm,
and the way you find them is interesting. It's you take in the old days, what you would do is you would take photographs and you would blink them, one photograph,
mm.
another photograph, and you would see something move. These days, everything is done on the computer. So
Computer.
you
Yeah.
you look at time lapse photography, and the computer will track moving objects. So there are all these asteroids that are found, and some of them have names, some of them don't have names.
Mm,
And so the International Astronomical Union has some protocol to name these
mm,
asteroids. And for some reason, the New Horizons spacecraft,
mm,
which I started working once they
mm.
finished their Pluto encounter, I had nothing to do with it before the Pluto encounter.
Pluto. Okay.
I started after the Pluto encounter. Once they started their
Mm,
astronomy mission, then it turns out that it's a great place to look at the dark sky, which is what I do. I look at the dark sky. But if you look at the dark sky from within the Earth's atmosphere, you still have to see the Earth's atmosphere. Even if you look at it from out of the Earth's atmosphere, from like I did with Voyager, you
mm,
still have to
mm.
worry about all this interplanetary stuff.
Enterprise. Yeah.
So
Yeah.
now that New Horizons is past Pluto, you don't have to worry about the solar system at all. So it's a great
Nice.
place to look at the dark sky. And so what you see is extragalactic light. And so that's my contribution to the New Horizons
Yeah.
mission. That I'm looking at the extragalactic light in the UV from there. And so they came out with this very nice policy. Anyone who is involved with New Horizons would get an asteroid named after them. And there's
Nice.
I don't know how many asteroids there are, tens of millions, hundreds of millions. So this is one asteroid. And some guy, a very nice guy. He's a software guy. He lives in
Mm,
Germany. He makes up these simulations, and
mm,
so he
mm.
simulated the
Yes,
it
yes,
would
I
be
saw
like
that.
very nice. So I'm glad that it gets people excited.
Absolutely, absolutely.
Yeah,
It's the real worthy way of making things public about these kind of things. It's a
it's
great
just
engagement. Yeah,
yeah, it's
it's a
an engagement. And we have
engagement.
to look for these.
Yeah,
We
absolutely,
have to look for ways to get people engaged.
absolutely. So, Jayant, please tell us about your current projects. What are you working on? And then, of course, we will end with your recommendations.
Yeah. So the three things. One is the New Horizon stuff.
Mm, mm,
That you because we're dealing at stuff at the edge of
Mm,
detectability. It's really tough that to rule out everything else. So I'm trying to finish that now. Hopefully that'll be
mm,
done in a couple of weeks, and then I've got more New Horizon stuff.
mm,
So
mm,
that's one thing. Another thing I'm doing is that I'm looking at all the galax data, and
mm,
again, this is also related to the UV sky, the dark UV sky. So it's a huge problem because you have so much data, and you're trying to reduce a complex problem into something that's understandable. So this is the way astronomy works.
mm,
Astronomy, you don't have the chance to go take data. You take what's given to you, and you try to understand it with models, and your models get increasingly complex, and you show the failure in your models. So there's a couple of things, and working with a couple of students on small projects, and we have our experimental group, which is working on building payloads for space. So what
nice.
we're trying to do is that the trouble is for us to build it is not a problem. We do things at a fairly low cost within the budget of our institute. So our cost
Mm,
is typically, let's say, 20 lakhs
mm,
for over 3 years, which is nothing. I mean, it's a lot for a person, but it's nothing for an
mm.
institute.
Yeah, yeah, you're right. You're right.
And this is a PhD for a student.
Nice.
So what we're trying to do is the launch costs are still expensive. So you're
Mm,
looking at $10,000 a kg.
mm,
And so for us, we're 5 kg, so that's $50,000, and we don't have that
mm,
kind of money. Is gets harder for us, 50, $100,000. And so we're partnering with these so-called new space guys,
mm. Oh,
are
okay, okay.
companies that are trying to go to space for whatever reason.
Mm.
We don't build satellites; we just build the instruments.
Instrument.
So they're
Okay.
happy to take us on their satellites, and because they're experimental payloads
Mm.
or they're experimental missions, so they say, okay, we'll take you, and hopefully we can help them attract interest because we're
Interest.
trying to do good science.
Yeah.
That's one of the things I insist in my group, that it's one of the things when you do instrumental work is you can always uh, do non-important stuff. You can do things in India. Very often we're trying to build things that are
Mm.
two generations behind,
Behind. Yeah.
and that's not it's difficult work. It's work that's good for the student. The student learns a lot, but it's not publishable work.
Publishing work. Yeah. Yeah.
It's not work that will get them jobs later
Mm.
on. And so we're fortunate to be in this new space era. The
Mm.
kind of stuff we're doing is actually unique, which is why the students do get jobs. And so we have a couple of options with a couple of companies,
Mm.
Space Rickshaw and Intercosmos. And
Mm.
we're
Mm.
trying to get launches next year. So
Fabulous.
the
Fabulous.
student who's just about to graduate, he had a star tracker that we flew on the PSLV, and we got good data from space. So that paper's just been published. And he
Nice.
also worked on a mission we were doing for the Chinese space station, for
Mm.
which unfortunately we have been unable to get MEA approval.
Oh, okay. Okay.
We've told them that it's pure astronomy. We're just looking up, but when you get to politics, it's a different kettle.
Different thing.
We have no
Yes.
control of that. So the two different groups. We have the instrumental group and the data analysis group.
Data analyst. Fabulous. Fabulous. Very nice. Very, very interesting. So, finally, give us some recommendations. What you kind of get inspired from. It can be anything you listen, read, or even arts, science, music, anything, even sports for that matter. What really inspires you? You mentioned that you hear podcasts. You can start from there, the history podcasts, and even
Yeah.
the astronomy. Yeah.
So as far as sports, what I've done for since high school is
Mm.
basketball.
Oh, oh, cool. Okay, okay,
I've
nice.
done basketball since I was 12 years old until I was 40. and we
Nice.
played every. I would do. I was a gym rat. Basketball 3 days a week, ultimate frisbee 3 days a week.
Wow. Okay.
Well,
Okay.
at least 2 hours every day was doing sports of some one kind or another.
Fabulous. Very
And now
nice.
my knees have gone, but so I do.
Mm.
Now I'm restricted to walking.
Mm.
But but so that I've always done. Always been some sort of athletics.
Mm.
Almost unique in my family
Mm.
to do
Nice.
some sort
Nice.
of athletics. And then I read quite a lot.
Mm.
Uh, I've been reading a lot of news over the last
Mm.
year, I guess, ever since COVID, and I think I'm going to start reducing that
Mm.
because it just takes up too much time,
Time. Yeah.
and so reducing that. I read uh, these days. My reading is well. Right now, I'm reading a history of science fiction.
Oh, nice.
Yeah, I've I've been reading some. So I basically I read anything that I can.
Mm. Mm.
I want to start reading Jack Reacher.
Mm.
I watched the
Mm.
TV series, so I want to see if the books are any good.
Voice good.
I don't know.
Yeah.
Yeah, and
Nice.
podcasts. I have a. I get. I listen to podcasts while I walk.
Walk.
So
Yes,
I get
that's the right time to.
two
Yes.
walks with the dog a day. It's 2 hours,
Fantastic. Yeah.
and then while I cook or something else, I get two
Mm.
and a half
Yeah.
podcast hours a day. So I have a bunch of history podcasts.
Nice.
Empire is quite good with
Empire.
Dallas.
Empires.
Yeah,
Yeah.
and
Yeah.
then I get a bunch of space podcasts. So I have Universe
Mm.
Today, This Week in
Mm. Mm.
Space. The Nature podcast is pretty decent, although
Yes.
sometimes
Yes.
over my head.
Mm. Mm.
I can't do listen. I can't do audio books
Yeah.
because
Yeah. It's
I can't concentrate.
mm. Yeah, same here. Even it's been similar experience to me. Audiobooks are slightly different. Although I did listen to 1984 on an audiobook recently.
Yeah.
It was interesting
That's a
because I
book.
wanted to see how yeah, how it was dramatized and other things. Because when you read it, it's slightly
I will never read that book again.
different.
It's just so powerful. I will. I read
It's
it when I was 18. I'll never read it again. I read Lord of the Rings. I keep going back to, but
okay.
or never.
Yeah, it is actually quite a little disturbing in that sense. Yeah.
Yeah. So this
Yeah.
is what I tell students. I tell students just read anything. It
Yeah.
doesn't have to be nonfiction. Anything.
Absolutely. Absolutely. Fabulous. Fabulous. Jayant, thank you very much for this fabulous, conversation, and thank you for sharing your knowledge and also your time in also motivating a lot of people in doing science the right way, in my opinion at least. And thanks a lot. It's been a pleasure
Thanks,
for me to
Pavan.
really have
Right.
you here. Yeah. So this is
Okay.
Pratidhvani, where we try to humanize science with the one and the only Jayant Murthy.
Bye.
Bye bye. Yeah.